Hi everyone, welcome to the Mathemagic channel. Today we're going to look at a Math Olympiad type problem, which is quite common, 25 to the x plus 5 to the x equal 20. So without further ado, let's get right into this. Okay, so there is some prerequisite knowledge to solving a question like this. The first one is, can we do a change of variable? The second bit of knowledge we might need is, can we factorize quadratics? And finally, to finish the question, we might need to know a little bit about logarithms. So I'll make sure to go step by step through all three of these bits for you. We can start with the change of variables. So noticing first here that 25 is actually 5 squared, we could say that this is 5 squared to the power x, followed by 5 to the x, and we can move the 20 to the left to make sure that we can have all the variables on the same side, which will make our life a little bit easier. And this is where your first skill is going to come in. Perhaps you could do this. You could say big Y is equal to 5 to the x. And what this will allow you to do is to change your expression to make it look more like a quadratic expression. So we're going to go ahead and do this. And so now we'll have y squared plus big Y minus 20 equals 0. And so we could generate negative 20 as a product by doing negative 4 multiplied by 5. And negative 4 multiplied by 5 is going to be equal to negative 20. But negative 4 plus 5 is also equal to 1, which is the 1y that we have in the middle here. And so this is going to be great to factorize our quadratic. If you're not too sure how to factorize quadratics, please refer to our video about how we factorize quadratics to make your life a little bit easier. And using this factorization, I can factorize this as y minus 4 factor of y plus 5 equals 0. Now when I multiply two things and I say that a times b is equal to 0, either a is equal to 0 or b is equal to 0. So in this case, it's no different. Perhaps we need the first bracket to be equal to 0 or the second bracket to be equal to 0. So for the first bracket to be equal to 0, y minus 4 should be equal to 0, which means that y is equal to 4. And for the second bracket to be equal to 0, y plus 5 should be equal to 0, which means y is equal to negative 5. And so replacing y by 5 to the x, I could say that 5 to the power x is equal to 4, or that 5 to the x is equal to negative 5. And so I'm nearly finished here. 5 to the x equal negative 5 is actually technically impossible, as a power of 5 must be strictly positive, so this is not going to have any solutions here. However, 5 to the x equal 4, that will have solutions, and so we can focus on this side of the equation. And the way that we can solve this is perhaps by using a graph or using a log calculator. So I'll show you how to use a graph first. And so on the Desmos calculator, as we can see here, which you can find on desmos.com, I've graphed 5 to the power x, which is the red curve, and you see as a power function that it's strictly positive. It's just over the x-axis and then it just goes up and shoots off to infinity. That's because it's a power function, it's exponential, so it's going to grow very quickly. And you notice here that I have also graphed the line y equals 4, which is a horizontal line, and that's the blue line. And so the blue line, y equals 4, is going to intersect 5 to the power x at 0.861. And that kind of makes sense because 5 to the power 1 is 5. So when we're trying to get 5 to the power x to be equal to 4, it's going to be a number that's a decimal value, but that's also a little bit smaller than 1. So 0.861 works, and if you were to go ahead and plug in 5 to the power 0.861 in your calculator, that would probably be very, very close to 4. So that's one way to do it. The other way to do it is to just use your calculator and use logarithms. Now, because we're operating in base 5 here, it'll be interesting to use the logarithm in base 5 to cancel the 5 to the power x. So I'm just going to go and write that down. And if we say logarithm in base 5 of 5 to the x, we have to do the same to both sides. We could say this is logarithm in base 5 of 4. And so for the left-hand side, logarithm in base 5 of 5 is going to cancel out. And so we're going to be left with our solution here, which is x equal log in base 5 of 4. and that is going to be very good for our final answer. In terms of how much this is equal to, I've taken the liberty to use the log calculator website, and you can see that I can just input here log in base 5, that's the little 5, of 4, and press the calculate key, and log in base 5 of 4 is equal to 0.861, which is the same value that we found on the graph. So whether you use your calculator or you decide to graph the curve against the line and see where they intersect, both solutions are absolutely fine, and that'll be the solution to this equation. So I hope this was useful and that you enjoyed turning this equation with a change of variable into a quadratic equation and solving using logarithms, since it's a power function. We'll be posting more videos related to Math Olympiad training and Math Olympiad problems, as well as quadratic equations. So make sure you like and subscribe to the Mathemagic channel. And remember that math comes easy with the Mathemagic channel. We'll see you on the next one. Thank you so much.